Assalamualaikum and hi. My name is Muhammad Farid Haikal bin Muhammad Zawi. So today I would like to present my PSM2. The title for my PSM2 is Static Wave Effect Simulation of Linear Low Density Polyethylene for the Application of Geotube Structure. My supervisor is Dr. Amullah bin Abdullah. So the funding of the industrial grant is with the collaboration with my flagship tank industry, Sdn Bhd, with the grant code M039. For presentation today will be based on the poster for my PSM2. Okay, first of all, I will present the abstract for my project. So, as we know, coastal erosion has long been a major issue on shorelines, wreaking havoc on coastline and public lands all around the country. This study was conducted in collaboration with my flagship tank Sdn Bhd, MOF. So, what is Geotube? Geotube offers an alternative for coastal protection due to ease of installation and less impact to the environment. A Geotube model will be established in the study to simulate using SolidWorks 2020 as a VR tools. So, the static wave effect on the linear low density polyethylene LLDPE Geotube will be based on Malaysia shore environment. So, MYF has proposed a new material for Geotube to replace the current material, which is by using GT750 engineered tube in order to develop a Geotube without the requirement of dewatering process. So this Geotube will be easy for the installation and more cost effective and time saving. The main objective of this study is to evaluate the LLDPE Geotube by simulate the stress, strain and displacement analysis for the Geotube design. Based on the simulation result obtained, the maximum allowable working pressure for the LLDPE Geotube is 130 kPa. In conclusion, the LLDPE Geotube was determined to be successful and capable of accommodating the value of wave pressure in Malaysia coastal environment. Okay, now let's move to the introduction. So, on the left side, GT750 engineered tube, and on the right side is my flagship tank LLDPE material. So, in this research, it was driven by the following problem. First, Malaysia coast has suffered significant erosion. Second, MYF has proposed a new material for a Geotube by using linear low density polyethylene to replace the current material using the GT750 engineered tube. So, in this project, we evaluate the Geotube structure capability under Malaysia shore environment. So, the objective of this study is to model LLDPE Geotube structure by using SolidWorks and then do the simulation due to the stress, strain and displacement analysis for the Geotube design structure and investigate the stress effect due to static wave effect for the Geotube structure design. Next, literature. So here are several literature that being used as a reference related to the title for this project. So first, a high strength synthetic fabric. It is used as a form for casting large unit by filling them with air, water, sand and screen for directive flow of geotite system. Second, linear low density polyethylene. LLDPE is a polymer that is mostly linear but has a lot of small branch, recognized for its long-term resistance to breaking under significant temperature change for being extremely flexible. So from here, all the material properties and the study about the LLDPE being the reference. Next, utilization of geotextile tube, which is the Geotube. This paper study the viability of Geotube in sandy and muddy beach, which is to analyze the simulation and the structure of the Geotube. And number 4, method for designing Geotube. In this paper, present a procedure that can determine the relationship between the tube of the size of the Geotube. Okay, now I will explain the methodology for this project. So, start by doing the problem identification as stated in the problem statement from the abstract in this video. So, after doing that, we move on to the first objective of this study. First of all, modeling standard size of Geotube using SolidWorks. After doing the structure, insert the LLDPE Geotube structure material in the drawing. After that, move on to objective number 2. Obtaining stress and wave effect parameter from the website that as the reference, which is by using myweather2.com, and then do the field simulation based on the data gain. After that, analyze wave effect and do some evaluation based on the result, and make the conclusion, and then report writing and end of this project. So the pressure wave value is taken and observed in the wave pressure value display on website myweather2 at several locations as shown in this table. So Kota Kinabalu, Kuala Terengganu, Kuching, Melaka, Muar, Port Dickson and Alor Setar are the reference point for the wave effect pressure. So here are the proposed design of the LLDPE Geotube. So the dimension for this structure: width 3 meter, length 10 meter, height 2 meter, and the thickness of this LLDPE is 3 mm. Okay, next I will present the result and discussion. So 5 different pressure have been simulated under static wave effect. This simulation begin at pressure of 100 kPa due to the fact that the data from myweather2.com website indicate the average minimum wave pressure is 100 kPa. So the next simulation will increase the pressure by 10 kPa until the maximum pressure gain and the geotube structure is filled. So in this result, 3 parameters were measured. First, von Mises stress. As you can see in the table, the data for von Mises stress increase as the pressure increase. When the geotube is subjected to 140 kPa of pressure, the von Mises stress reached 13,704 kPa. The value for the von Mises stress exceeds maximum pressure the geotube can withstand. When the pressure applied to the LLDP geotube is increased beyond its maximum capacity, the LLDPE geotube will fail to bear the pressure. Second, displacement. So displacement is result color contour plot that depict how far the model have moved from its original position. Total display the displacement magnitude regardless of its direction. According to the observation, the difference between the displacement values before reaching the maximum level is small, but when the value exceeds the maximum value, a large difference between the displacement value can be seen. Next, strain. Strain refers to the geometric response from change caused by the force applied, which is the pressure. Strain is a sort of deformation that occurs when a force is applied and cause physical change in the size or shape of a geotube. So the strain values increase as the applied pressure increase. According to the observation, because the LLDP geotube is unable to bear the applied pressure, a substantial variation in strain value is observed when the applied pressure surpasses the maximum permissible value. So, for the conclusion, after doing the simulation, the maximum allowable working pressure for LLDPE geotube is 130 kPa. The highest value of wave effect in a Malaysia shore environment from myweather2.com website is 101.4 kPa. As consequences of the investigation, the proposed LLDPE geotube was determined to be successful and capable of accommodating the value of wave pressure in the Malaysia shore environment. For future study, can introduce compression stress into the structure to evaluate the tensile strength of the LLDPE. This LLDPE geotube can be used to replace the GT750 engineered tube from Tekata Sinar Berhad for the application of geotube structure in order to eliminate the dewatering process for the geotube. Last but not least, I will highlight acknowledgement for my project. I would like to thank my Flexiteng Sinar Berhad for giving opportunity for me to run this research. Cooperation from my Flexiteng giving response about the research is highly appreciated. So here are some reference used to complete this research. That's all from me. Thank you.